Hi guys, last class we learned about how to measure far away objects distance just like nearby stars. So we will learn about parallax method. So with the help of parallax angle, so we measure the distance of nearby star or planet. Now today's class I would like to discuss how to measure small length. Suppose to measure a length of small length. Small means it is the order of 10 power minus 3 or smaller than this 10 power minus 6 or the smaller of this 10 power minus 9 so far. So under the measuring methods to measure the order of the 10 power minus 3. So 10 power minus 3 we are calling milli. So you know about this instrument? Yeah, this instrument is known as microscope. So microscope is having the ability, depends upon the instrument. It is having the ability to see the objects up to order of the 10 power minus 3, the size. So just like bacteria or any kind of cell which is having the size 10 power minus 3 to up to 10 power minus 6 within the range, we can use this microscope. So this microscope do not comes under the measuring method, but it is an instrument. Suppose if you want to see an objects which is smaller than that, the objects of nearly the size of an electron. So this instrument is known as electron microscope. So this instrument we will use to find the sizes on the order of the 10 power minus 12 or greater than above that ones. So this is a very highly sophisticated instrument. So that's precise information it can give. Suppose you can see this the diagram. So this diagram which is the image of the electron microscope. Suppose if this is an ant, if you can see closely how this ant picture, if you can able to locate the eyes of an ant, so how clearly the image is magnified. Not only that, the hairs and everything, even though if you can notice the ant teeth and mouth, everything. So this gives highly magnified image, the electron microscope. But by using certain method, so not any instrument, certain method, process, not any instrument. So by using certain method, so in this method we don't use any instrument but certain process we can use. So with the help of the process we would like to find the up to the size of the 10 power minus 9. So we are using a method for particularly, this is an outdated method, but for a rough approximation we can use this method, especially to find the molecule size of the order of the up to 10 power 9. So today we would like to measure the oleic acid. The oleic acid, the size roughly comes, this is the more bigger in size among the all that ones. So today we would like to measure the oleic acid. Oleic acid, OLEIC. You can cut that. So the oleic acid size we are going to measure by using measuring method. So this is the smallest size we are going to able to measure with a method. So to measure the size of oleic acid, so instead we need to consider the oleic acid. This as an organic compound. So my task is find the molecular size of the oleic acid. For that, first of all, we need to dilute that. Suppose if I take the needed things, it's the oleic acid and alcohol, water, lycopodium powder and scale. So first of all, take 1 millimeter, sorry, 1 ml. So you can take as in 1 ml of oleic acid. It's 1 ml, 1 ml of oleic acid. Or 1 ml you can think otherwise like this. Suppose if you are having a cube of volume 1 centimeter cube. This is a cube of volume 1 centimeter cube. So in this one, how much liquid can becomes? So that is we known as 1 milliliter. Now we are adding 1 milliliter of oleic acid to a 19 ml of alcohol. So if we are adding 1 ml of oleic acid to 19 ml of alcohol. So because 1 ml plus 19 ml together it will become as a 20 ml. So in this 20 ml only 1 ml is the oleic acid. Now after adding that, so we can get the 20 ml of the solution, we can get it. Now from the solution we can take again 1 ml. So from this solution, so this 1 ml is taken from it here. From the solution, now we are adding to another 19 ml, another 19 ml of alcohol. Now here why we are doing that? So we want to confirm that by decreasing the concentration. Now here we can see, now 1 ml add you at here, from here to you can add again at here. Now from here to here it is a concentration decreased as in 1/20th ml. It means 1 ml of the oleic acid is a part of the total, and from here to here it decreases as in 1/20 times 20. So now the oleic acid concentration has decreased. Now finally we can take that after diluting the things. So the concentration of the oleic acid is decreased. How much it is decreased? The concentration of the oleic acid decreased 1/20th times 20th, because so from this total we can take it. So that is the decreasing of the concentration of the oleic acid. So that much amount of the concentration is decreased. Now finally what we need to take? So finally from this we need to take the 1 ml for our experiment. So for our experiment, so here we will take 1 ml with the help of a dropper. Now if I take from here volume of 1 drop, so with the help of dropper if I take the volume of up to 1 ml, so from the diluted solution of the oleic acid, suppose if I take 1 ml, it means I know how much volume I am taking. So volume I took, volume of diluted acid. So with the help of the dropper I can take that as 1 ml. Now, if you drop this whole 1 ml with the help of a dropper, so the dropper will be gives in terms of the drops. Now, the volume of this oleic acid what you have taken, which is equal to number of drops times the volume of each drop. After taking 1 ml from the diluted solution, now we need to do further step. So we need to put that in water. So while we are putting the water, so we will drop with the dropper. So what the dropper can do? Dropper will be drops in terms of the number of drops. Suppose this 1 ml gives to me as a 15 drops. So I can make it equal 1 ml equal to number of drops is 15 drops times the volume of each drop. Now here you will ask a question, sir, how you find that volume of each drop? So how we can find the volume of each drop? Suppose if we know the radius, of the drop, so then we can able to find its volume of each drop. And if we can multiply that volume of each drop with the number of drops, so that number of drops which equal to how much volume we have taken. So from the dropper we already know how much amount of the volume we are taking. So for the experiment I am taking as 1 ml. So that 1 ml I will drop in the water. So in terms of small drops. So the total volume what I have taken in the water will convert it into number of drops times volume of each drop. Suppose here you can see the professor is doing the same experiment. So he has taken the oleic acid of 0.5 percentage. So that is 0.5 percentage of oleic acid in alcohol. So now he is going to drop that in the water. Now if you can see, that is the compound structure of oleic acid. Now from that oleic acid, so we are using one of the dropper. So from the dropper, so if you take 1 ml of the oleic acid, so with the help of the dropper we can measure how much volume we are taking. Now here you cleanly observe he is dropping in water. So this is in a water plate. This is in a water plate. If you can closely observe that in water. Now the oleic acid after dropping the water, it spreads. If you can see that clearly one more time. So after dropping that one, so if you can observe, so something is spread on the water surface. Now how much it is spread? So it will spread like a circle. So if it is spread like a circle, if you can able to measure that circle, how much it is spread. Now he is measuring the spread of the oleic acid in the water. So if you can able to measure how much is spread of the oleic acid on the surface of the water. So what happens, usually oleic acid contains alcohol component also, but alcohol components in this case it gets evaporates. So only oleic acid small layer will be forms on the surface of the water. So we will measure that surface with the help of a graph paper, or some graphical method is also exist with the help of a graph paper or with a rough measurement. So here it also getting as a perfect circle because he has taken the circular plate of water. Now the circle he is measuring the diameter. Now if you measure the circle diameter, so from that we can get easily the radius. So finally I can write the theoretical process. Suppose if you can take a volume of n drops, volume of small n drops which we put in the water, drops of solution. So the volume of n drops, we can take number of drops times volume of each drop. So we can write that in terms of centimeter cube. Now amount of or concentration, amount of oleic acid in this solution. So if you can take this much amount of the volume, so in this volume how much amount of oleic acid is present, because we diluted that. So when you can dilute it, we diluted that twice with the 20 centimeter cube. Automatically the amount of oleic acid in that dropper solution will be reduces. So how much we can write that? We can write that number of drops times how much volume we have taken. So 1 over 20 times 20 centimeter cube. So here I have mentioned that number of drops times volume of drop. So this is the amount of oleic acid is solution is present. Now this solution of the oleic acid is spread over the surface of water. Now this solution spread on the surface of water. Now if you find the area of spreading of water, spreading of oleic acid, if you find the area of the spreading of oleic acid, so we know that how to find we need to find the size, or size is also nothing but thickness. So we have taken volume of we know that volume of solution or volume of the film after spreading divided upon area of the film. So if we can divide the volume upon by area, we will left over the thickness. So we can find the thickness of the spreading oleic acid on the water. So that thickness is equal to molecular size. So this molecular size we can calculate up to the order of the 10 power minus 9 meters. So if we can substitute that, the above the components in this expression, the thickness we can get the volume of the drops. So n times v times 1 over 20 upon 20 centimeter cube upon area. If you can take A is the area of the film, it is the centimeter square. So you can cut that. So you can left over the final expression, that is n times v upon 20 times 20 times A is centimeter is the thickness. So this thickness only here we need to calculate that in terms of molecular size. So final expression we can able to get is the order of the 10 power minus 9 method, 10 power minus 9 meters. So this method gives some not accurate result but some approximation result, but usually we don't follow these ones, but for the just understanding purpose, how to measure a small sizes by using measuring methods. So this is one of the explanations which is given in our syllabus. So try to get it.